want to go see it or you're not clear about something, you can always go back. Remember, every single whiteboard meeting is saved and is put on the whiteboard slides. I am going to share my screen so that we know what we're talking about. Cool. So for no very good reason, I'm just going to start with this one. So this, and again, like this is nothing special. I just figured this would be a good place to start the conversation. So Elliot, Hillary, Isabel, Lowell, Joy, do you guys want to talk to us a little bit about what you did here and why you did it and what it means?
I guess the first one is similar to the third one, except instead of drag, it's your hand holding it up.
Mm-hmm.
And of course it's active, or not active, of course it's the same amount of force or constant congruent, because we have congruency lines. Otherwise it would be like floating up or falling down. And then the second and third one are basically the same, except the drag is not congruent with the gravity and therefore not constant.
Okay. So anybody has any ideas about how to make this from like a great answer to like a phenomenal answer? How do we reach the phenomenal state? Like what are some features that can be improved on this force diagram? Yeah, just share.
On the before, I don't know if this is on purpose, but it looks like your lines are like a little crooked for the congruency marks.
Oh, interesting. Okay. Yeah, there's no actual like convention for whether the lines have to be perpendicular to the arrow or not, or it really depends. But they have to be, yeah. So that's an interesting thing. Hayden, you had something you were about to say.
Yeah, for the start, you have congruency marks on one, but not the other.
They're not there on my Jamboard. I don't know.
They're not there. Which one's your Jamboard?
No, like on this Jamboard on my screen, they're not there. So I don't know why they're. Yeah.
Try to refresh your screen. See if that's like refresh your window.
So I think I don't think those are supposed to be there. I think someone might have erased them already.
Oh, really? Well, that's unfortunate. I like them. Okay, let's see what, oh, yeah, you're right. Somebody did remove them. Okay, so any thoughts about force diagram 1 or 3? Things that we can do to improve them. When we draw an arrow, where does the arrow start? Always.
At the dot.
At the dot, right? So make sure your arrows touch the dot. What does it mean? So there's a congruency mark for the two arrows. What does it mean about the two arrows? Are they congruent? Are they equal? Are they like, what's the deal?
The forces are equal.
The forces are equal. Maren, what do you think about that statement? The forces are equal.
Wait, they're equal in the first and the third diagram?
The first and the third?
Yeah. I mean, they have congruency marks, so I think that they'd be equal, because if they weren't equal, then why would there be?
You were doing so well. They're congruency marks, therefore they are what?
Balanced.
They're balanced. That's a great word. They're balanced. They have the same size.
Magnitude? Oh,
right?
size.
Same magnitude?
Yeah.
Are they equal though, those two forces?
No, because then it would just be floating, right? Or
why are those two forces? Why is the normal force by the hand and the gravity not equal? Keen.
Oh, it's because, well, if they were equal, then they'd either both be going down or both going up, but they're going in opposite directions.
They would have to have the same direction, right? Forces have directions and magnitude. So congruency marks just need to have the same magnitude, same size. They're balanced, but they're not equal, right? They're not equal. Okay, so on the first diagram on the left, right? Those two forces are congruent. On the one on the right, the two forces are congruent. People have used the same congruency marks here and there. Is that a mistake? Is that true? Is that okay? Can we live with that?
Oh, yeah, actually. Yeah, I think so, because gravity is the same no matter what. And so the other forces have to be the same no matter what.
So it makes sense that you would use the same congruency mark here, 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 and there, because those two forces are balanced. Those two forces are balanced, and the gravity does not change. Question, is there another congruency mark that we could put on this diagram? Natalia, who I have not heard from in a while. Is there another congruency mark I can put on this diagram? Yes, right? And that would mean that all 5 of these arrows have the same size, which is true, they do. Any questions about the congruency marks, about the force diagrams? Can we stop zipping blue lines there? Thank you. Okay, so let me stop sharing. Let me